Good morning, students. How are you? Are you ready for learning? Okay. Today I will discuss about a force which is acting on moving charge in uniform magnetic field. Okay? Force on a moving charge in a magnetic field. Okay? Here, cross sign indicates magnetic field, uniform magnetic field. Vector B, magnetic field is a vector quantity. Okay? A charge particle of plus Q charge moving inside the magnetic field, and due to effect of the magnetic field, its direction of velocity changed and goes upward for making angle theta with respect to the horizontal. If magnetic field is not present here, then charge particle is without any disturbance, goes in this straight line path. Okay? But due to effect of magnetic field, F Newton of force is acting on it. F Newton of force is acting on it. Okay? This force depends on the following factors like F variages Q, that means the force acting on this charge particle is directly proportional to the magnitude of the charge. Okay? F variages B. B is the magnitude of the magnetic field. F variages V sin theta. Here V sin theta is the vertical component of the velocity of the charge particle. Okay? V sin theta becomes effective because the direction of velocity changes in the upward direction and its horizontal component is V cos theta and forms angle 0 with respect to the magnetic field and becomes ineffective. Okay? Here only V sin theta is effective. Now we have combining them, combining we have, okay, F variages Q into B into V sin theta. That implies F is equal to K into Q B V sin theta. Where K is a constant, where K is a constant and k is equal to 1. From experiment, the value of k is 1. From experiment, the value of k is 1. From experiment, the value of k is equal to 1. Okay, that implies f is equal to q b v sin theta. This is the expression of the force. This is the also a formula of force in the case of magnetic field. Okay, in the vector form, in the vector form, it can be written as vector f is equal to q into vector v cross vector b. This is the vector form of force acting on charge particle in the case of magnetic field. Okay, here special cases are arised. Special cases are arised because final derivation of the magnetic force sin theta comes. So, special cases are arised if theta is equal to 0. That means if the direction of both velocity and magnetic field is same, then which amount of force is acting on the charge particle? Okay, if theta is equal to 0, if theta is equal to 0 degree, if theta is equal to 0 degree, then f is equal to q b v sin 0 degree. Do you know value of sin 0 is 0? That implies f is equal to q b v into 0. Therefore, f is equal to 0. Hence, this shows that if the direction of velocity of charge particle and magnetic field is same, then there is no force is acting on the charge particle. Okay? Next, if theta is equal to 90 degree, then f is equal to q b v sin 90 degree. The numerical value of sin 90 is 1. That implies f is equal to q b v into 1. That implies f is equal to q b v. This is the maximum value of applied force due to the magnetic field. Okay, if third is here, if theta is equal to 180 degree, then if theta is equal to 180 degree, then f is equal to Do you know value of 180 degree is sine 180 degree is 0. Therefore, F is equal to QB V sine 180 degree. Okay, F is equal to QBV into 0. Therefore, F is equal to 0. Hence, in this case, acting force is 0 also. Magnetic field is right side and moving charge, velocity of charge particle is left side. Therefore, there is no relation or interaction between both velocity of the charge particle and magnetic field. Hence, acting force will be 0. Okay? We can also derive this formula in the case of current. Okay? Magnetic force in the case of current. Okay? We know that F is equal to Q B V sin theta. It is clear? Okay?